Hi, this video is going to go over the word problems from section 6.4, Algebra 2, week 11. When you look at a two-digit number like 85 and you let t be the tens digit and 5 be the units digit or ones digit, you wouldn't write tu to represent the number 85 because we know that two variables beside each other means multiply. So what we need to remember is that the 8 or whatever number is in the tens place needs to be multiplied by 10. So the number would be 10t plus u, which means in this case 10 times 8 plus 5, that's 80 plus 5 or 85. Okay, here's a summary. If t equals the tens digit and u equals the units digit, then 10t plus u would be the number. And if you reverse the digits, that means you need to take 10 times what's in the units position and then add t. The sum of the digits is t plus u, and tu would be the product of the digits. So let's look at a couple of those. Okay, here's the first problem we want to look at. The sum of the digits of a two-digit number is 12. If the digits are reversed, the new number is 18 less than the original number. What's the original number? Now, as soon as you see that you have a two-digit number, when it says of a two-digit number, when you see you have a two-digit number, you should automatically know that you're going to have let statements that look like this. Okay, so I've got t equal the tens digit, u equal the units digit. Now remember what we said before, the value of the number is 10t plus u. So it says the sum of the digits is 12. That part's easy. So I've got t plus u equals 12. Now it says if the digits are reversed, the new number, which is 10u plus t, is, that's my equals, 18 less than, so we stick the 18 out the back door, 18 less than the original number. Well, the original number is 10t plus u. Alright, now, if you have two variables, you must come up with a system of two equations. And the first thing I'm going to do is put those two equations in the same format. Now when you look at the second equation, I notice that there's a common factor of 9. If you notice that, you're always welcome to divide through and make a simpler equation out of it. I can divide all the way through by 9 as long as I do each term of both sides of the equation. And that will give me a new system. Now this new system, because I divided through by 9, it's already set up to do addition. So I'm going to go ahead and add them together and I get 2u equals 10, which means u is 5. Okay, once you find u, then you have to go back up to one of the original equations. I'm going to take the first one and find out what t is. If u is 5, t must be 7. Okay, now I still need to do my check. So 10 times u, 10 times 5, plus t, which is 7, equals 10 times t plus u, and then minus 18. So I get 50 plus 7, that's 57. And on this side I get 70 plus 5 minus 18, which is also 57, so it does check. Okay, that's my step 4. Now make sure that you answer the question that's being asked. Don't tell me that t is 7 and u is 5. You're supposed to tell me what the number is. The number is 75. Here's our next problem. The tens digit of a two-digit number is 5 less than the units. When the digits are reversed, the sum of the original and reversed numbers is 43. What's the original number? Okay, now again, when you see that you've got a two-digit number, most likely you're going to have let statements, let t equal the tens digit, let u equal the units digit. Now, it says the tens digit of a two-digit number. Now, that prepositional phrase, of a two-digit number, just tells you that you've got a two-digit number instead of like a three-digit or a four-digit. the two-digit number isn't actually part of the statement. If you can leave that out and just say to yourself, the tens digit is 5 less than the units. So my first equation is the tens digit is 5 less than the units. Okay, so that's the first equation. Now I have to come up with a second equation. Look at the second sentence. When the digits are reversed, the sum of the original and the reverse numbers. So I've got the sum of two things is 143. Now what I'm adding here is the number and the reversed number. So the number is 10t plus u. The reverse number is 10u plus t. Now before you go doing anything else, you probably want to clean up that second equation, because if I look at the first one, this is set up very nicely to do substitution. But I can save myself some work if I will clean this equation up first. So that's what I'm going to do. Okay, now as I said before, this one is set up nicely for substitution. So where I see a t here is where I'm going to substitute u minus 5. So that makes my equation, I'll just put it down here, I've got 11 times t, so that's where I'm going to put my u minus 5 plus 11u equals 143. So as I solve this, I get u equals 9. So now I'm going to take that, and I'm going to come up here, and I have to find out what t is. So take that top equation, t equals u minus 5, and put in 9. I get t equals 4. Okay, now I still need to check that in the other equation. So 10 times t plus u plus 10 times u plus t equals 143. I'm going to run out of room. Okay, so when I check that, I get 40 plus 9 plus 90 plus 4, that's 143, so it does check. Alright, so I need to put my number 4 over here, and then make sure step 5 answers step 1. You're looking for the original number, so that would be 49. So I would say the number is 49. An investor has $150,000 in two different accounts. One earns 7% annually and the other earns 6.5%. How much is invested in each account if the total annual interest earned is $9,900? Now, I wrote down my find statement and then I did those familiar buckets. But we're going to do this problem. We could do it with one variable, but we're going to do this with two. So what I'm trying to find is the amount invested in each account. And if you remember right, that's what we put in the bottom of the bucket. So I'm going to put X in the bottom of this bucket, Y in the bottom of this bucket. Now my percents, I've got 7% in one account, 6.5% in the other account, and it's for annual interest, so that tells me I've got 1 year. Now, because it gives me a total annual interest, that's all I'm going to put in this bucket. Now, if you want to, I do have $150,000. You could put that in the bottom of your bucket, but put it in a cloud, because you're not going to multiply that when you multiply the other buckets. Now, for my equation, because I have two variables, I need two equations. First of all, I know that the two amounts have to add to $150,000. The second thing that I do is I multiply my buckets. I have 0.07 plus 0.065 y, and that equals 9,900. Alright, now the first thing I would do is look at clearing my decimals. I can clear the decimals in this equation, if I multiply all the way through by 1,000. So let's do that. Now, any way you look at this, whether you're going to use substitution or the addition method, you've got some pretty large numbers. So get your calculator out and be real careful and solve the system. Okay, you can see that I chose to do this by substitution. I went through the problem and I found x is 30,000, so y is 120,000. I did my check and I wrote my conclusion. What happens when you do systems of equations with two variables for word problems is you don't have to do a lot of thinking until you get to step 3. You just put your x and your y in, and then when you get to step 3, then you have to kind of come up with your two equations. Okay, let's look at one more. A man has $37,000 in a passbook account and $43,000 in a money market account that pays 10% more interest. What is the interest rate of each account if his total annual interest income is $8,500? So I'm looking for two interest rates. So normally I just put my interest rates in my buckets, and that's what I'm going to do. Those are my unknowns. You do need to realize that they are in decimal form. A variable cannot be a percent. So whenever you have to put like a rate or a percent into an equation, you need to realize that both of these variables, when they come out, when I find out what x and y are, they're going to be decimals. I'm going to have to change them to the percent. Okay, so let's keep going. My total annual interest income is $8,500. And the only other thing I need would be the amounts. And I know that I've got 37,000 in one, and I've got 43,000 in the other. So let's get our two equations. First of all, how do x and y relate to each other? It says that the money market, which is where we put our y, that interest is 10% more than the interest rate x. So y is 10% more than x. So 10% more than x. Okay, now, remember what I talked about as far as the decimal form? I can't leave 10% with a percent sign in an equation. That has to be changed. This 10% has got to be changed to a decimal. So that would be 0.10. Alright, and then for my second equation, I'm going to multiply my buckets. I've got 37,000 times x plus 43,000 times y equals 8,500. Alright, it's time to solve it. This one is set up pretty nicely for substitution as long as I don't clear the decimals. So let's look at that for a second. I've got 37,000, 43,000, 8,500. Do you see that there are two zeros at the end in common with all of them? That means I can divide through by 100 and get those numbers to be a little nicer to look at. So let's see what that does for us. Okay, so I'm just going to go ahead and do the substitution. I know there's a decimal there. Okay, when I solve that and do the substitution, I get x equals 0.0525. Y is 0.1525. Okay. Now, I better check those. Now, one thing you do need to remember, this is in decimal form, so this really stands for 15.25%, and this one really stands for 5.25%. Okay, so now you can write your conclusion. Therefore, the passbook pays 5.25%, and the money market pays 15.25%.